Hello everyone and welcome to this training session on actuarial common entrance test ACET. Uh, as a part of this session, let's look at the mathematical foundations subject. And in this subject, the chapter which we are going to cover now is algebra. There are quite a few things from our schooling world which are required to be brushed up as a part of this particular chapter, including solving simultaneous equations, solving quadratic equations. So a few important aspects from the exam standpoint. So let's look at the various important aspects that go as a part of this chapter, right? So let's get started. We are starting off with understanding the laws of indices. So there are three common laws. Probably if you go back to your schooling world, you can easily try to correlate these kind of laws. Let's say I have x cube multiplied by x squared. So which is nothing but x to the power of a multiplied by x to the power of b. It works out to x to the power of a plus b. So 3 plus 2, I can very well write it as x to the power of 5. So whenever we see that two different numbers having the same base x, having the same base x are multiplied together, you can simply get their result by adding up their exponents. By adding up their exponents, that would be the resulting result. So this is one of the important laws you can keep in mind. So even if someone says x to the power of 2a multiplied by x to the power of 4b, it's nothing but x to the power of 2a plus 4b. So it can be used even for solving some kind of unknowns. So it can be used for a lot of purposes. A simple addition of the exponents, right? So you remember that kind of a law. Then we are talking of the second law here, simply x to the power of a divided by x to the power of b. So again, the base remains the same for both of them, but the powers are different. Then that resultant works out to x to the power of a minus b, which is the subtraction between the two exponents. So if I say x squared divided by x cubed, I will simply write it as x to the power of 2 minus 3 or x to the power of minus 1. Remember, x to the power of minus 1 can always be written as 1 by x to the power of 1, or which is nothing but 1 by x. So probably I would like to add one more rule. X to the power of minus n, I can easily write it as 1 by x to the power of n. So probably you can remember this also as one of the rules which can help you for solving a lot of calculations, right? So wherever you come across such kind of a rule, try to apply this kind of a formula, and you can simplify it in some cases. Now, one of the other important law of index which you should be comfortable with is whenever x to the power of a is raised to some other power, let's say b. So x is first raised to a, and that resultant, whatever x to the power of a is raised to the power of b, which means it is multiplied those many times, which will work out to nothing but x to the power of, just multiply the two exponents and remember it. So whenever I say x squared whole cube, which is nothing but x squared is multiplied 3 times, which is nothing but the exponents are added. So here the power is multiplied and makes it x to the power of 6. Remember, this is not the same as x to the power of 2 to the power of 3. Bracket makes a difference here. X squared, when it is put in bracket and on the top of that there is a power, then only this kind of this kind of simplification happens. But if let's say the same x2, 3 are put in this format without a bracket, the first way to simplify it is first simplify this power separately. 2 cube is 8. So this becomes x to the power of 8. So you have to remember this rule very carefully in this case. X is power of a whole to the power of b is not the same as x to the power of a to the power of b. The difference is only the bracket. So here it becomes x to the power of ab, whereas here it becomes x to the power of a to the power of b. So you have to be careful with these two kind of calculations. So applying them in the real world when you come across the numericals of this kind is the key of understanding the law of indices. I hope you are comfortable with this particular aspect. Try practicing a couple of numericals. Take some random numbers, x power 7 by x to the power of 3.5, whatever it is. All this works. It need not be the case that a and b are integers. No such rules. As long as the bases are same and they are multiplied, the exponents can be added. They are divided, the exponents can be subtracted. One is raised to the power of other, the exponents are directly multiplied. And please be aware that there is no such rule for x to the power of a plus x to the power of b. So only for multiplication, division and raising to the power you have these kind of law of indices. Don't get confused with that aspect there. Alright. Okay. So the next concept which we are looking at in this context is the logarithms. Logarithms are very closely linked with the law of indices. Logarithm is nothing but a simple way of writing. Let's say if x power a is some b, then what we are saying is the exponent can be written as the logarithm of b to the base x. This is the kind of a relationship between the exponents and the indexes and the logarithms. So what it is telling me is this power is an important aspect in the logarithm. To what power a particular number needs to be raised in order to find out the logarithm. So when I say 10 squared equal to 100, we can simply say 2, which is the exponent, is equal to log 100 to the base 10. This is the way we are defining the logarithms. So logarithms as well as the indices are linked in this particular manner. Now what we are seeing is the base. Here the base is 10. Here the base is x. So any number can be the base. But the world of logarithms believes in two major bases to a large extent. So if the base is 10, we call them as common logarithms. And if the base is e, we have discussed about e to a large extent in our earlier chapters, 2.718. If the base is e, we call them as natural logarithms. Right? So the most common in the financial world, the most common logarithms we talk of are e. So even in your calculators, they are mentioned separately under the name as ln, whereas the common logarithms with a base 10 are mentioned with log. So that's one thing you have to understand as far as the logarithms is concerned. And just like you have three main laws with respect to indices, you have similar kind of laws with respect to logarithms also. And those typical laws associated with the logarithms are simple. Probably I'll try to link them up with your indices formulas. So let me try to link them up with the indices formulas. So when you say as an index formula x to the power of a into x to the power of b is equal to x to the power of a plus b. Now the way it works out in case of logarithms is log x plus log y, whether it is ln or log doesn't matter, is equal to log xy. So here what you are seeing with respect to indices is if they are multiplied, you add up their exponents. Whereas here the two logarithms, if they are added, whatever be the base, let it be a or 2 or e or 10, whatever it is, if the bases are same, I add two logarithms, the result is the multiplication of those two values. That is what is the kind of relationship between the two. Similarly, x power a divided by x power b is what we said as x power a minus b. The same thing when I bring it into the logarithm world, log x by log x minus log y. So whatever is in the division form in the index, that gets translated into the subtraction form, and whatever is the subtraction form, that gets translated into the division form. So this is one more important rule as far as the logarithms is concerned. And the power rule, you can write it as log x to the power of n. If you any base is anything, you write it as you bring the power to the front and you say n log x to base a. So these are the three important rules as far as logarithms is concerned. So let me try to take up a couple of quick examples to solve that kind of scenario. So when someone says find the value of log 2 plus log 3, so it's not log 5, it becomes log 6 because we are doing the multiplication. Then log 5 minus log 2, it is not log 3, it becomes log 5 by 2 or 2.5. And log 2 to the power of 5 is same as 5 into log 2, 5 times log 2. These are the rules that will come out as a part of the usage of these laws of logarithms. So whenever we talk about whenever we are talking about a product, you can split that product into the individual logarithm sums. The division, you can split that as the subtraction between the individual logarithms. And one more thing is logarithms are defined only for positive numbers. Any number they are defined, but they are defined only for positive. They are not defined for 0. They are not defined for negative. But the value of the logarithm can still be negative. The value of the logarithm can still be negative. So what I mean to say is, if we are talking about log x base a equal to b, then x should definitely be a positive number, but b, the answer, can still come out to be a negative number, right? So this is one more thing which you have to be comfortable with when we are talking about logarithms. I hope you are comfortable with this concept of logarithms as of now. So the moment you put these things into a bit of practice, things become more and more clarified for you. But yeah, you have to remember the laws of logarithms because they help us in solving lots and lots of numericals as far as various applications in the world of actuaries is concerned. Then the next aspect. So till now we have looked at the indices, and then we have started looking at the logarithms. The next aspect we will look at is fractions. How do I simplify a fraction? Basically, there are multiple ways of simplifying the fractions, right? So let's take example by example. If suppose I come across a fraction of this form, where there is something in the numerator, so there is some variable in the numerator, some variable in the denominator. So if this is the form, the typical method which I can use to solve these kind of stuffs is the LCM kind of a method. What are we doing in that method? Okay, let's do this. 2x plus 3 by x plus 1 minus 3x plus 2 by 6x minus 1. Now the LCM of this is nothing but the product of these two things. Simple. X plus 1 into 6x minus 1 is the product. And in the here x plus 1, x plus 1. So what is left is 6x minus 1. So here you write it as 2x plus 3 multiplied by 6x minus 1 minus, same way as here, 3x plus 2 into x plus 1. Now what is happening to your numerator here? So 2x into 6x, it's a simple simplification. I hope you should be comfortable with this simplification process. 12x squared plus 18x minus 2x, which is plus 16x minus 3. This is the first expansion. Then what about the second one? 3x squared plus 3x plus 2x, which is plus 5x plus 2. And probably you can simplify the denominator also, which becomes 6x squared minus x plus 6x, which is plus 5x minus 1. So and under simplification, 12x squared, and here I have minus 3x squared, so making it 9x squared. I have plus 16x minus 5x, so it becomes plus 11x minus 3 minus 2, making it minus 5, divided by 6x squared plus 5x plus minus 1. If there is some more way to simplify it, we can simplify it. Otherwise, we can leave it like this, which can give me my answer. That is the simplification here. So this kind of simplification, especially when I am given two different fractions, and I have to simplify the value of the two different fractions, I can resort to the LCM kind of a method. This is the same as we solve typical numbers itself. If someone asks for 1 by 2 minus 2 by 3, we do it exactly the same way. Now that this expression is in the form of x's instead of 1, 2, 3 kind of numbers, we see that probably there is some difficulty that comes out. But if the concepts relating to the simplification there are same, even here you can apply the similar kind of a process itself. So that is one way you will simplify the fractions. So because this is a multiple choice kind of an exam, probably you can sometimes check out by substituting something for x and in all the answers also, and let's say probably you can as a simplified thing, this will work only in certain cases. Probably I'll say substitute x equal to 0. What will this become? 3 by 1 minus 2 by minus 1. So 3 minus of minus 2, what we are getting is 5. What I can simply do is quickly substitute 0 in all the answers, whatever are given, all the answer choices. Quickly try substituting a 0 for x. So even here, if this is one of the answers that is given, if I substitute 0 for x, I get minus 5 by minus 1, which is nothing but 5. So this is matching. So probably I can mark it as answer. But the problem comes if there are 3 or 4 answer choice, all the 3 or 4 answer choices that are given, they get they get evaluated to 5 itself. That is where the problem comes up. Otherwise, I can still use my these kind of workaround logics to simplify these kind of problems without in fact getting into all this entire complication. But yeah, if the answer contains none of the above or something like that also, probably I don't suggest you to use that shortcut mechanism. I suggest you to go with this lengthy process itself in terms of finding out the final simplified value. All right. So this is one way you simplify the fractions. Now the second way, if you can split it into factors, let's say look at the next numerical here, x squared minus 3x minus 4 divided by 2x squared minus 7x minus 4. This is called as a method of factorization. You break it into factors. How do I break it into factors? I have to identify, especially if I have a quadratic equation like this, I have to identify the two factors of this number or multiplicate the two fact. Let's say I have something of the form ax squared plus bx plus c. Then identify the factors of AC. Factors are two numbers multiplied together should give me a value which is equal to AC in such a way that their addition should be equal to B. That is what we call them as factors. So probably here what is AC? I'll do it with two of them, you will get comfortable. 1 and C is minus 4. So I need to find the factors of minus 4 in such a way that when I add those two, it should be equal to minus 3. So when I multiply them, it should be equal to minus 4. When I add them, it should be equal to minus 3. So I know that if I take minus 4 and 1, it is satisfying my scenario. I multiply these two, I get minus 4. I add these two, I get minus 3. So I can say minus 4 and plus 1 are the factors. Now once I know that, what is the story here? I will simply write it as x plus 4 into x minus 1. Just change the signs and write it. Sorry, x minus 4, keep the signs as it is and write it. X minus 4 into x plus 1. These are the factors of this. Now let's try the denominator. It makes things easier for us. I have to identify two numbers whose product is equal to AC, which is minus 8, and their sum should be equal to minus 7. Now you can very well tell me minus 8 comma minus 1 plus 1. Their multiplication will become minus 8. Their summation will become plus 1. So the simplified way for you to write it, even a better simpler way, is 2x squared. Write it as minus 8x plus x minus 4. Now what happens? You take 2x common out of the first two. It becomes x minus 4. You take 1 as a common out of this. You take x minus 4. Now you take x minus 4 out and you say 2x plus 1. So this becomes x minus 4 into 2x plus 1. So it becomes, I can simplify x minus 4 and I will write it as x plus 1 by 2x plus 1. So this happens to be the simplified equation. Especially if I have to do a factorization, I can do it in this kind of a mechanism. So any factors, right? So let me take one more example for you to get a hold on it. 3x squared plus 8x minus 3x squared plus 3x squared plus 8x plus 5 divided by 2x squared plus 9x plus 7. Let's say these are the two. Now what I can do here, so I need to take two numbers in such a way that their product is 15 and sum is 8. I can write them as 5 and 3. 5 and 3, their product is 15, the sum is 8. So what I'll do is I'll write it like this: 3x squared plus 5x plus 3x plus 15 divided by, how do I write this? Here I need two numbers whose product is 14, whereas the sum is 9. I can take 7 and 2. So I'll write it as 2x squared plus 7x plus 2x plus 7. Now out of the first two, take a common out. I'll take only x out for the first two. It becomes 3x plus 5. And in the second, there is 3 out. So it becomes no, it. Oh, here it's not 15. Here it's 1, 5. So I'll take 1 out. So it becomes again 3x plus 5. The denominator also I'll do the same. I'll take x out for the first. I'll get 2x plus 7. And out of the next part, I'll take 1 out. I'll get 2x plus 7. Again in the numerator, I'll take 3x plus 5 out, making it x plus 3. Similarly, in the denominator, I'll take 2x plus 7 out, making it x plus 1. Oh, sorry, even the numerator is also x plus 1. So I'll simplify these two and I say 3x plus 5 by 2x plus 7. So this is the method of solving using the factorization. You should be comfortable with solving through this method because you need to identify the factors and then simplify the numerical. Right? Then one more process that exists in terms of simplification of the fractions is the division. Whenever a division is given to you, my advice to you is take it as the reciprocal of the multiplication. 2x squared minus 5x minus 12. Because this division is given, make it as a multiplication and take it as the reciprocal into 2x squared plus 5x plus 3 divided by x squared plus 3x plus 2. Simple. Let's simplify all these things using our factors. I need two numbers whose product is minus 2 and the sum is minus 1. So minus 2 and 1 are my numbers. So the first one I will write it as x squared minus 2x plus x minus 2. I hope you are comfortable here. Now denominator. Multiplication should give me minus 24 Addition should give me minus 5. So I'll make it as minus 8 and plus 3. I'll get the same, right? So you should be a bit fast in this. 2x squared minus 8x plus 3x minus 12. Alright, now here multiplication is 6, addition is 5. 3 and 2, correct? So I'll write it as 2x squared plus 3x plus 2x plus 3. Now denominator, x squared plus 3x plus 2. Multiplication is 2, the addition is 3. 2 and 1. So x squared plus 2x plus x plus 2. Now it becomes simple for you. Now in the first one, take x out, make it x into x minus 2, and take 1 out, make it 1 into x minus 2. Right? Denominator, first two terms, take 2x out, 2x into x minus 4. The second terms, take 3 out into x minus 4. You should get the same commonality in both. So again here, take x out in the numerator, make it into 2x plus 3. Take 1 out of the next two terms, make it 2x plus 3. I hope now you are getting the hold a little bit on this. Even in the denominator, take x out, make it x plus 2. Take 1 out and make it x plus 2. Now the next step, whatever is common, take that out. X minus 2 into x plus 1. It became multiplication overall. Now the denominator is 2x plus 3 into x minus 4. Here also 2x plus 3 into x plus 1. And what about the denominator? Denominator is becoming x plus 2 into x plus 1. Now things are easy for you. You strike out x plus 1 both in the numerator as well as denominator, and probably 2x plus 3 also both in the numerator as well as denominator. You are left with x minus 2 into x plus 1 divided by x minus 4 into x plus 2. If simplification is required, you simplify it by multiplying the two and make it as one term, or leave it like this. Depending on the answers, you can choose which of the options. But the point here is, if at all any fraction is given to you for simplification in terms of a division, make it as a multiplication by multiplying it with its reciprocal. These are some of the mechanisms that you need to look at for simplifying the fractions. Right? So let's move on to the next concept here. Now we are talking about the next important concept in this situation, which is called as the quadratic equation. Any equation which is of the form ax squared plus bx plus c equal to 0, which means there is a squared somewhere for x. So if there is a square existing in some of the terms, that is what we call it as a quadratic equation. Now we can write this quadratic expression or equation, because there is an equal to. We can write this quadratic equation in the form of two linear expressions, linear terms, dx plus e into fx plus g. Whatever is the squared term, that entire thing can be broken into two parts, where there is no squared term in the broken part, there is only the linear form in the broken part. So if I can write ax squared plus bx plus c equal to 0 in the form of dx plus e into fx plus g equal to 0. So if these two things are the same, then what we are saying is the roots or the values of x. So this particular equation has two values of x. Why are we saying 2? Because the power is 2. Depending on what is the power, we'll talk about that particular equation will have those many values for the unknown. Now in this case, I can say that x can have two different values, or two values. They may be different, they may be same. X can have two values, and those two values are nothing but minus E by D and minus G by F. That is what is the definition of quadratic. So if I substitute minus E by D wherever is possible in this x, I will get 0. Similarly, minus G by F, if I substitute, I will also get 0. So these are the two solutions for the values of x. So whenever we are talking of quadratic equation, the main intention is to solve for the unknown values, which is the value of x. And if I am able to express it in the form of dx plus e into fx plus g equal to 0, I can very well say that minus e by d and minus g by f are the roots of the quadratic equation. So, just like the way we have solved the earlier fractions, the same logic can be used here. Now, let's say if I want to talk about 3x squared plus 8x plus 5 equal to 0. Now, I'll show the different methods. The first method is try to break it into factors like that. Sometimes it is easy to break it up into factors. We have known that you take two numbers whose product is 15 but the sum is 8. So I'll take 5 and 3. So I'll write it as 3x squared plus 5x plus 3x plus 5 equal to 0. Take x out of the first one, 3x plus 5 plus 1 out of the second one, 3x plus 5 is equal to 0. Now this makes it 3x plus 5 into x plus 1 is equal to 0. Now this is what is this form. I'm able to write that entire ax squared plus bx plus c in this particular form. So that means x I can write it as minus 5 by 3 or minus 1. So these are the two possible values, which mean wherever x is there in this expression, you substitute x equal to minus 5 by 3, you will get it equal to 0. Or you substitute minus 1 into that equation wherever x is present, you will get the value as 0. That is what is the root. Whenever I substitute those values which I have got back into the equation, I get the values as 0 itself. So that is what is an important result that needs to be remembered. So based on that, some of the important results you have to go with are a squared minus b squared is nothing but a minus b into a plus b. So if I get probably x squared minus 4, which is nothing but x squared minus 2 squared. So I can very well write it as x plus 2 into x minus 2. That's how the result becomes very handy. If at all I am observing something in the form of a squared minus b squared, I can very well write it as a plus b into a minus b. Similarly, a cube plus b cube, which is nothing but like x cube plus 2 cube, 8. I can write it as x plus 2, going with that formula a plus b into a squared minus ab plus b squared. I can directly write these things in this form. Similarly, x cube minus 8. So I'll write it as a minus b into a squared plus ab plus b squared. If you remember some of these rules, writing or simplifying your expressions become more and more easy. So whenever we talk about the roots of the quadratic equation, there are one method is use this factorization kind of a method. Create a factors and based on the factorization try to identify the root. Or for any kind of stuff, the straightforward method is a formula. Whether you are able to break it down or not able to break it down into roots, whatever it is, you don't bother. If you are sometimes, if you are not able to create the formulas or if you are not able to identify the factors, don't worry. You use this formula, you will get the two possible values of x. Now for the same, 3x squared plus 8x plus 5 equal to 0. So you don't need to even think of your factors. Use this formula, minus b. So always write it as ax squared plus bx plus c equal to 0. B is 8 here, a is 3 here, c is 5. Minus b, minus 8 plus or minus square root of b squared 64 minus 4ac, 4 into 3 into 5 divided by 2a, 2 into 3, 6. So it is coming out as minus 8 plus or minus 64 minus 12 by 60. So 4 by 6. So it becomes minus 8 plus or minus 2 by 6. It gives me minus 8 plus 2, which is minus 6 by 6, minus 8 minus 2, minus 10 by 6. So we have got the answer which we have got even through factorization, minus 1 comma minus 5 by 3. So this formula is something which is universal. If at all you have some equation in the form of ax squared plus bx plus c equal to 0, I can find all the possible values. So any such kind of equation will have only two possible values of x, and those two possible values can directly be found out using this formula, minus b plus or minus square root of b squared minus 4ac by 2a. So you can very well write it. You just need to be comfortable with the calculation, but once you are comfortable with the calculation, you will get your answer. So you don't need to really bother about, am I able to factorize it, why am I not able to factorize, what so am I not able to strike up with the factors. You don't need to bother about it, and because this is being a multiple choice kind of an exam, you don't need to really bother about the factors, what process you are actually following to arrive at the factors, right? So you can directly apply at your formula and arrive at your factors through this mechanism. So please be comfortable with the formula minus b plus or minus square root of b squared minus 4ac by 2a to solve this particular expression. Then the next set of things that we need to be comfortable with is solving the simultaneous equations, which is nothing but two variables will be given in all these equations, and I have to find out the two variables. So let's look at if they are in the linear form like this, 2x plus 5y minus 4 equal to 0. I need to find out the values of x and y. 7y equal to 2 minus 4x. The simple process. So first write one in terms of other. Probably here, let's say y equal to 2 minus 4x by 7. Fine. So this is your first step. And now what you do is you go and put this value for y in the first equation. 2x. You can do it either way. 5 into y. 2 minus 4x by 7 minus 4 equal to 0. Now this entire thing is only in the form of x. 2x plus 10 by 7 minus 20 by 7x minus 4 equal to 0. Please be comfortable. So now if I take LCM, 14x minus 20x minus 6x by 7, and what about 10 minus 28 minus 18 by 7 is equal to 0. So so you can very well minus 6x by 7 is equal to 18 by 7. So you cancel out 7, x equal to minus 3. So once you know x equal to minus 3, you can very well find out the value of y. Y equal to 2 minus 4 into minus 3. 4 minus 12. So it becomes 2 plus 12 by 7, making it 14 by 7, which is equal to 2. So now I know x equal to minus 3, y equal to 2. This is a method of solving the simultaneous equations if both of them are linear. Try to express one of them in terms of the other and again repeat the process. That's a straightforward. Of course, one method is if the direct answers are there, you just substitute the answers back, x and y, into both the equations. So let's say if the answers are given as 1 comma 4, 2 comma 3, minus 3 comma 2, something like this. You substitute 1 comma 4 into this equation as well as this equation. If in both the cases the answers are true, left hand side is matching out with the right hand side, those are your values. But sometimes what happens is he will not simply ask the values of x and y. Sometimes he may say find probably x plus 2y. In that case, there is no other alternative. You have to solve for x and y and then only try to find out the value of x plus 2y. So you have to be comfortable solving the equation. The first simple thing is from one of the equations, exhibit x in terms of y or y in terms of x, and then take that value into the other equation and do the simplification process. That is the simple way to solve any of these equations. Now, another example let me take up. Let's look at the second one. If they are non-linear, how do we address? Same process. X squared plus y squared equal to 20. 2x minus 3y equal to 14. Now, the better thing is establish x or y in terms of the other from the linear one, not from the squared one. So, you write 2x equal to 3y plus 14 and x equal to 3y plus 14 by 2. Now, take this value of x and put it here. 3y plus 14 by 2 whole squared plus y squared equal to 20. Straightforward. Simplify it now. 9y squared plus 2a squared plus b squared plus 2ab. b squared is 14 squared, 256 plus 2ab, 2 into 3, 6 into 14, 84y by 2 squared, 4 plus y squared equal to 20. Now simplify it taking an LCM across. So it becomes 9y squared plus 4y squared. 13y squared plus 84y plus 256. Now because there is a 4 in the denominator, even LCM gets applied here. It becomes 80. The other way it becomes 13y squared plus 84y plus 176 equal to 0. Now, if you are able to identify the factors, well and good. Otherwise, you can use your formula. Minus b minus 84 plus or minus square root of b squared. b squared is 84 squared minus 4ac, 4 into 13 into 176. Because you will be having your calculators, even this big number is not a problem. 2a26. So use your calculator to simplify the process. 84 squared minus, you start your brackets, 4 into 13 into 176. Close your bracket, so it becomes Okay. So it is coming out to, so in the inside it is coming out to a negative number. So if it comes out to a negative number, then there is no root defined, which means it becomes very difficult in terms of handling your values of x. So it's a straightforward. So try out minus b plus or minus square root of b squared minus 4ac by 2a. Let's see if we have made any kind of a mistake. If we have not made any kind of a mistake, then this is not a problem at all. 2x equal to 3y plus 14, x equal to 3y plus 14 by 2 whole squared plus y squared equal to 20, 9y squared plus 14 squared is 256. Oh, 14 squared actually is not 256. Let me correct it. 14 squared is 196. This is where we made a problem. All right. So let's correct it. So this is 196. And if this is 196 here, this becomes 116. So now again, let's try out our expression. So don't make any such kind of calculation mistakes. So let's go back again. 84 squared minus bracket 4 into 13 into 116. Oh, this, let's see. Yeah, this is better. 1024. And you take the square root of that. You take the square root of 1024. How do I find out the square root? Probably here I don't have the square root function, so I'll take x power y itself and I say 0.5. That is what is the square root. So I get it as 32. 32 is the square root of 1024. It's better if you remember them, but otherwise you have your calculator, so you can use them. So minus 84 plus or minus 32 by 26. Now minus 84 minus 32 by 26 is one of the roots. So which is nothing but minus 116 by 26, or it becomes minus 52 by 26. So minus 52 by 26 is minus 2, whereas minus 116 by 26. So 116 by 26 is something 4.46 something. Okay, so let's try using both of them. So 4.46. So I have two values for y here. One of those values is 4.46, whereas the other value for y is minus 2. Minus 4.46 and minus 2. So I can very well substitute x back here. So x equal to, if I take minus 2, it becomes 3 into minus 2, which is minus 6 plus 14, 8 by 2. It comes out to x equal to 4. So one solution is x equal to 4, y equal to minus 2. Whereas the other solution is, okay, I substitute minus 4.46. So it becomes 3 into minus 4.46. How much I get? 3 into minus 4.46 plus 14. Okay, let's try out. Minus 116 by 26. Right? So this is the number. So I put a minus to it. Minus 4.46 into 3. This is what I get. Plus 14. This is what I get. Divided by 2. So the other number happens to be my 0.30. So either my solution is x equal to 0.3 and y equal to minus 4.46, or x equal to 4, y equal to minus 2. So these are the two different solutions of x and y that can come out from here. Again, from your answer choices, you can very well try marking that too, because x squared is there. It's a quadratic equation, and there is a definite possibility of two roots existing for this kind of an equation. So whenever you have non-linear equations, the simple suggestion is look at your linear equations, and based on the linear equations, you substitute the one into the other in the non-linear one, and try to derive at the value of your equation. I hope this process is comfortable. Otherwise, you practice one more similar thing, and the simple way to check it out is you substitute the answers what you have got back into the both the equations. The left hand side should match with the right hand side. That's a simple way to check out whether you have done correctly or not. Now, the third method is, especially if your data is like this in the form of a product, ar squared equal to 8, ar cube plus ar to the power of 4 equal to 30. And here you have even cross. There is no linear here. Both are non-linear. One is with the second power, the other is with the third. But probably what you are observing is ar is something common in all the terms. They are in the form of a multiplication. Whenever they are in the form of multiplication, the simple way is divide. Divide this by ar squared, divide this by 8. So what you end up with is, for the first term your r, and for the second term you are having r squared is equal to 30 by 8. With a cross multiplication, you get 8r squared plus 8r equal to 30. I will write minus 30 equal to 0. Now again you can find out your r using the formula minus b plus or minus square root of b squared minus 4ac by 2a. I'm not even thinking of factorizations. Okay, now let's use our calculator. 64 minus 4 into 8 into minus 30. So 30, and I put minus. So I get it as minus 960. Because there is a minus before, I can remove the minus and I can simply add up. So make it plus 64. So it becomes 1024, and we know that the square root of 1024 is 32. So this becomes minus 8 plus or minus 32 by 16. So it becomes 32 minus 8, 24 by 16, which is 3 by 2. Minus 32 minus 8 minus 40 by 16 minus 5 by 2. So r is either 3 by 2 or minus 5 by 2. So that is the way we are. So now we are getting our r as 3 by 2 or minus 5 by 2. So from here I can proceed. Okay, ar squared equal to 8. Now if I take r equal to 3 by 2, I'll get a into 9 by 4 is equal to 8, which means a equal to 32 by 9. Even that is so one solution for a and r is 32 by 9 comma 3 by 2, and the other one is, if I take r equal to minus 5 by 2, a into minus 5 by 2 whole square, 25 by 4 is equal to 8. So a becomes 32 by 25. 32 by 25 comma minus 5 by 2 is also one more solution for this case. So whenever we have some kind of non-linear equations where they are tied together through multiplication, we can do this kind of solution also. So better you practice even this kind of scenarios also. And one more method is, you can do a factorization for each one of them. So you see this kind, 2p squared minus pq minus 3q squared equal to minus 50 divided by Oh, sorry. The other one is 3p squared plus 4pq plus q squared equal to 35. So what you can do is divide both the numerator and denominator by q squared. So what you are getting? 2 into p squared by q squared minus pq into q. So pq by q squared, which becomes p by q minus 3. 3 into q squared by q squared. Let's say equal to minus 50 by q squared. Similarly, divide the other one also. So what you can very well do is, okay, 3 into p squared by q squared plus 4p by q plus 1 equal to 35 by q squared. Now what you can do is take it as a quadratic equation. Assume that p by q is some x. So I can very well write this as 2x squared minus x minus 3. And the denominator I can write it as 3x squared plus 4x plus 1, right? So using your factorization, what you can very well do is you can write it as the multiplication should be minus 6 and addition should be minus 1. So I'll take it as minus 3 and plus 2, right? So probably it becomes x plus 1 into 2x minus 3. You can do the simplification part. X plus 1 into 2x minus 3. Same one, the multiplication should be plus 3, the addition should be 4. So 3x and x. So it becomes x plus 1, 3x plus 1 into x plus 1. So I know this is the scenario here, x plus 1 is getting cut off. So what I'll do is I'll divide these two. That is where these two are getting cut off. So I'll make it as 2x minus 3 by 3x plus 1 is equal to minus 50 by 35. Here I can find out the values, right? I can simplify. I can get the value of x. X is nothing but p by q. I can solve out for the value of p by q. Once I know p by q, okay, let me solve it. So it becomes 70x minus 105 equal to minus 150x minus 50. So 220x equal to 55. And from here I'll get x equal to 1 by 4. If x equal to 1 by 4, x is nothing but p by q equal to 1 by 4, which is nothing but q equal to 4p. Now I can go back. Wherever q is there, I substitute 4p. Now substitute in the first equation. 2p squared minus p into 4p minus 4p squared minus 3q squared. 3 into 4p squared. 3 into 4p squared is 3 into 16p squared. 48p squared is equal to minus 50, which is giving me, so this is working out to minus 50p squared is equal to minus 50. So p squared equal to 1 and this comes out to p equal to plus or minus 1. This is one aspect. Now again I can do the same. If p equal to plus or minus 1, q will be equal to plus or minus 4. So if p equal to 1, q equal to 4, p equal to minus 1, q equal to minus 4. As simple as it. Now I am getting all my answers there. So this is one more way of solving. But yeah, if the answers are directly given without any complication in the question, Like, okay, if the question talks about find p plus q or find 2p plus 3q, when those kind of questions are there, there is no other alternative. You have to solve first, find out the values of p and q, and then simplify your process. Otherwise, if it is more in this form, you can directly substitute your answers and even try out on the calculations also. So that is one way. So you have to be comfortable with various mechanisms of solving the simultaneous equations, right? More and more practice will give you more and more comfortability in solving these kind of simultaneous equations. All right. Okay, let's move on to our next section. So sometimes we come across inequalities instead of equations. We come across inequalities instead of equations, wherein the whole solving remains one and the same, but the only difference being we'll not get one exact value, but we'll get a range of values. And that is what we are calling as inequalities. So all that you are doing with the equation, you have to do the same process here also, but with small changes. Now let's take up some of the examples. Whenever I am getting something which is talking about less than, then I can very well say that the x lies between the two roots which I get. See, let's say, okay, we'll talk about this 2x plus 11 into x minus 7 less than minus 57. Now, we do it just like any quadratic equation. I'll tell you, 2x squared expanded, 2x squared minus 14x plus 11x minus 3x minus 77 less than minus 57. Make it like 0 itself. 2x squared minus 3x minus 20 less than 0 up to here. Now imagine that it is 0, it's equal to 0 itself, and solve it as a quadratic equation, which means x is minus b plus or minus square root of b squared minus 4ac, 4 into 2 into minus 20 by 2a, which is 4, 3 plus or minus 8 into 20, 160, 169. 169 square root is 13 by 4. 3 plus or minus 13 by 4, which means I get them as 16 by 4, which is 4, or 3 minus 13 minus 10 by 4, which is minus 2.5. Up to here it is the same. Now the only thing we are talking of is, okay, now x is not equal to these two. The only thing is, when I see that there is a less than sign here, I'll say that x lies between these two values. X lies between minus 2.5 to plus 4. Whenever I see a greater than sign here, I say x does not lie between these two, rest all it is fine. So if the same question had been greater than, my answer would have been, okay, x does not lie between minus 2.5 and 4, which means x is less than minus 2.5 and x is greater than 4. It does not lie between minus 2.5 and 4. This is how we solve for the inequalities. Everything, you solve it just like a quadratic equation. You arrive at your roots. Until that the process is the same. The only thing is, instead of taking that the values of x is equal to this, we'll talk about whether it lies within the range or does not lie within the range. If I see a greater than symbol, I say that it does not lie between those two values. If I see a less than symbol, I say that it lies between those two values. Let me solve this question also, simplify for you. 8x squared plus 5x minus 7 less than or equal to, probably I'll do a cross multiplication directly, 6x squared plus 10x minus 4. Take it to the other side, 2x squared minus 5x minus 3 less than or equal to 0. X, if I am able to find the roots, fair enough. Otherwise, I'll try to find out x using minus b plus or minus square root of b squared minus 4ac, 4 into 2, 8 into plus 3, 8 into minus 3, minus 24. So it becomes 49. Divided by 4. So it comes out to 5 plus or minus 7 by 4. So 5 plus 7, 12 by 4 is 3. 5 minus 7 minus 2 by 4 is minus 0.5. And because there is a less than or equal to sign, I can very well say that x lies between minus 0.5 and minus 0.5 and 3. And because there is an equal to, even these values are also included in the interval. Even minus 0.5 and 3 are also included in the interval. But if I am talking about only less than, I'll say that these points are not included, which means I'll put a simple normal bracket itself. So this is the way we solve any kind of inequality related questions, right? So the remaining part of this chapter I'll take as a part of another session. We have a few more things, especially relating to the binomial expansions and progressions and various other aspects. I'll take them as a separate session. But whereas as far as this session is concerned, we have looked at indices, logarithms. We have got into solving of the fractions, simplification of the fractions, then quadratic equations, and solving simultaneous equations, and looking at the inequalities also. I hope you got a good level of insight into all these aspects. If you have any further queries regarding any of these topics, I suggest you can call me on the number given below, 98480 I request you to send me an email on Vamsidhar at facegurus.com with explaining your queries and clarifications required, and also request you to visit my website www.facegurus.com for any further updates regarding the training and the consulting and corporate training programs we do in the areas of finance, analytics, and actuarial sciences using tools like Excel, VBA, and SPSS. I hope this session has given you a good amount of insight in terms of preparation for your ASET entrance exam. Your feedback is most welcome. Thanks a lot for listening to this session. Thank you very much.